Hey everybody, welcome back to Demo Hub Pod, exploring the cutting edge of tech and AI, powered by AI. We're going to be diving deep today.
Into neural networks.
That's right. And to really get a handle on this, we've got a pretty incredible stack of sources here.
Yeah, we do.
Excerpts from the NeuriPS 2024 conference, some background on Andrew Ng, and then like the real in-depth technical stuff from textbooks like deep learning, and even some popular articles too, just to see how it's all being, explained to the average tech enthusiast out there.
Yeah, it's fascinating to see that bridge between like the hardcore math and then what people are actually using every day without even realizing it.
So, okay, first things first. What is the neural network? Like, it seems like everything points back to the human brain as the inspiration for this whole thing, all those neurons and synapses and all that.
This is a really good analogy. Just like those biological neurons, artificial ones process information.
Okay.
But instead of electrical signals, they use mathematical functions. And the connections between them, they have these weights that can be adjusted. And that's how the network learns.
So it's like our brains, but built with numbers and algorithms instead of cells and all that biology.
Exactly. And just like our brains have different areas for different jobs, neural networks are organized in layers. So you've got the input layer where the data comes in, then hidden layers where the real processing happens, and then finally the output layer, which spits out the results.
I can already see how this could get really complex, especially with those deep networks that have just tons and tons of those hidden layers.
Oh, yeah.
But before we even get there, let's talk about how they actually learn. It's got to be the really cool part, right?
Absolutely. There are a few different ways they learn, but the main ones are supervised, unsupervised, and reinforcement learning.
So from what I've read, supervised learning sounds like the most, I guess, straightforward one. Like you're giving the network labeled data.
Right.
It's kind of like, a teacher with examples and the answer.
That's a great way to put it. So imagine you're building a system to predict how much a house will sell for. So you feed it a bunch of info about houses, like square footage, number of bedrooms, the location, and you also give it their actual sale prices.
Okay.
So the network is trying to figure out the relationship between those factors and that final price. And the goal is to get its predictions as close to those real prices as possible.
So it's making these guesses, getting feedback on how close it is, and then adjusting to get better over time.
Precisely. It tweaks those connection weights based on how far off its predictions are. And, over time, it gets surprisingly good at predicting prices for new houses that it's never even seen before.
That's honestly pretty mind-blowing. But what about unsupervised learning? Like, how does it learn without someone, holding its hand and giving it the right answer?
Unsupervised learning is more about pattern recognition. Think of it like how a kid learns to group objects without being explicitly told what each object is. They just kind of notice similarities and differences and then start making their own categories based on those patterns.
So it's less like a student and more like a detective almost, looking for clues and connections in the data.
You got it. A great example is Andrew Ng's work at Google Brain. He trained a neural network on YouTube videos to recognize cats.
Oh, wow.
But here's the thing. The network never had cat defined for it. It just learned by analyzing, millions of images and figuring out the patterns that made cat pictures different from everything else.
Whoa, that's incredible. But I bet that took like a massive amount of data and just insane processing power.
Yeah, you're absolutely right. That's actually one of the big challenges with deep learning. And speaking of challenges, let's move on to reinforcement learning, which takes things to a whole new level.
Okay, so this is where the network's like interacting with an environment, kind of like learning to play a game, right?
Exactly. Think of it like a character in a video game navigating a maze. So the network doesn't get a set of instructions, it just takes actions and gets rewards or penalties depending on the outcome.
Interesting.
And through this trial and error process, it figures out which actions lead to the best results.
So it's kind of like training a dog with treats, right? Like good actions get rewarded, bad ones don't.
Yeah.
But how does this actually apply to real world problems?
Well, this is actually how things like self-driving cars are being developed.
Oh.
The network learns to drive by constantly making decisions based on sensor data. So the rewards might be things like, staying on the road, avoiding collisions.
Makes sense.
While penalties come from, going off course or getting too close to other vehicles. It's powerful stuff, but it can be incredibly complex to set up and manage.
This brings up a question for me. If these networks need so much, like computing power. How can something like Siri on my phone use them for speech recognition?
That's a great question. And it's where advancements in hardware come in. So powerful GPUs, which were initially designed for graphics, are now being used to train and run these complex networks much more efficiently.
So our smartphones are basically packing mini supercomputers these days. That's wild. Okay, so we've got this basic idea of what neural networks are and how they learn, but let's actually get into the nuts and bolts of how they work. What are the algorithms and functions that make all this magic happen?
Let's start with backpropagation. It's a core algorithm for training neural networks.
Okay.
Essentially, it figures out how to adjust those connection weights to improve the network's predictions.
Right.
To understand backpropagation, we first need to grasp the concept of a cost function.
A cost function.
Yeah, so think of it as a measure of how wrong the network's predictions are. The lower the costs, the closer the predictions are to those actual values.
Okay.
And backpropagation uses this cost function to guide its adjustments, nudging those weights in the right direction to minimize the error.
Okay, so backpropagation is all about tweaking the network to hit the bullseye, so to speak.
Right.
But how does it actually know which way to tweak those weights?
That's where things get really clever. Backpropagation uses calculus, specifically a concept called gradients, to figure out how much each weight contributes to the overall error. It then adjusts the weights in the opposite direction of their gradients, essentially descending towards a lower cost.
So it's like a hiker trying to find the lowest point in a valley. They keep walking downhill, following the steepest slope until they reach the bottom.
That's a great analogy. And another key piece of the puzzle is activation functions. These functions determine how each neuron responds to its input. And they introduce what we call nonlinearity, which allows the network to model complex relationships in the data.
Nonlinearity. What does that actually mean in this context?
Imagine trying to predict a house price based only on its size using a straight line on a graph.
Okay.
That's a linear relationship, simple and predictable, right? But real-world relationships are rarely that straightforward. House prices can be influenced by all sorts of factors, like location, amenities, market conditions.
Yes.
Activation functions allow the network to capture those nuances, kind of bending and curving its predictions to better fit the complexities of real-world data.
So it's like adding curves to a road instead of just driving in straight lines all the time.
Exactly. It allows the network to navigate a much wider range of possibilities. And all of this, from the layered structure to the learning algorithms and those activation functions, is what allows neural networks to do some pretty amazing things.
And we're talking some seriously impressive applications here, right? Things that are already impacting our lives in a big way.
Oh, yeah. Things like speech recognition in those voice assistants we use all the time.
Right.
Image tagging on social media, even self-driving cars like we were talking about, navigating all those complex environments.
Right.
Neural networks are behind all of that.
It's really amazing to see how these applications are already a part of our daily lives. But all this power and complexity, it can be a little intimidating, honestly.
Yeah.
Where does someone even begin to wrap their head around all this if they want to start working with neural networks?
Well, it's true that they can seem like a bit of a black box, especially with all that math involved.
Right.
But the good news is you don't need a PhD to get started. There are tons of resources out there that can help you understand the basics and start building your own networks.
So where would you recommend someone begin?
Yeah.
What are some good resources or courses for, getting up to speed?
There are some fantastic online courses available, and many of them are free.
Oh, wow, really?
Yeah, so Coursera, for example, has a really popular course called Neural Networks and Deep Learning, taught by Andrew Ng.
Oh, wow, the cat guy. Isn't he a legend in the field?
He is. He's a pioneer in AI and machine learning, and his courses are known for being super clear and comprehensive.
It's really amazing how these online platforms are making high-level knowledge accessible to everyone.
Yeah.
You don't have to be at a fancy university to learn from the best anymore.
Yeah, that's one of the things that excites me most about this field.
Yeah.
It's becoming more and more inclusive.
Right.
And that's only going to accelerate innovation.
So online courses are a great starting point.
Yeah.
What about books? Are there any that you'd recommend for someone who wants to really dive deep into the theory and the math behind all of this?
There are many excellent books out there.
Yeah.
But one that's considered a must-read is Deep Learning by Ian Goodfellow, Yoshua Bengio, and Aaron Corville.
Okay.
It's like the Bible of deep learning, covering a huge range of topics, from basic concepts to advanced techniques.
Oh, wow.
Yeah, it's great.
I've heard great things about that one. And I remember seeing another book mentioned in our research.
Yeah.
Pattern Recognition and Machine Learning by Christopher Bishop.
Yes.
I think it takes a slightly different approach, right?
Yeah. Yes. Bishop's book is a classic, and it's especially helpful if you're interested in the statistical foundations of machine learning.
Okay.
It dives deeper into probability and Bayesian methods, which can give you a more nuanced understanding of how these algorithms work.
Okay, so we've got some solid recommendations for the theoretical side of things.
Right.
But let's talk about actually building these things. Like, what are some essential skills or programming languages that someone would need to know?
Python is definitely the go-to language for neural networks.
Python.
Yeah, it has a really rich ecosystem of libraries that are specifically designed for this kind of work.
I've heard of libraries like TensorFlow and PyTorch.
Yeah.
Are those the ones that, like, everyone's using these days?
Those are the big players.
Okay.
So TensorFlow, developed by Google, is known for being very flexible and scalable. So it's great for handling massive data sets and complex models.
Oh.
PyTorch, developed by Facebook, is often favored by researchers, and it's known for being more user-friendly and intuitive.
So it's like choosing the right tool for the job.
Yeah. Do you have a preference? Honestly, both libraries are fantastic.
Okay.
And they're constantly evolving. They're always improving.
Yeah.
I'd recommend trying out both and seeing which one kind of clicks with you.
Okay.
The important thing is to have a solid understanding of the concepts and principles behind neural networks. Once you have that, you can adapt to any library or framework.
That's great advice.
Thank you.
But it's not just about the code, is it?
No.
I feel like there's a certain way of thinking that's crucial for working with neural networks effectively.
Absolutely.
What would you say are some of the, like, less technical skills that are essential for success in this field?
You're absolutely right. It's not just about memorizing syntax and algorithms. You need to develop a deep understanding of how these networks learn, how they process information, and how to optimize them for specific tasks.
Right.
It's about thinking like a neural network, in a way.
So it's about understanding the why behind the code, not just the how.
Exactly. It involves developing skills in data analysis, feature engineering, and model evaluation.
Okay, let's break those down a bit. Data analysis seems pretty straightforward. You need to understand the data you're working with, right?
Right. You need to be able to clean the data, identify patterns, understand relationships between different variables.
Okay.
If you put garbage data in, you're going to get garbage results out.
So data analysis is like making sure the foundation of your house is solid before you start building the walls.
Perfect analogy.
Okay, cool.
And once you have that solid foundation of clean, structured data, you move on to feature engineering.
Feature engineering sounds a little more technical. What's involved in that?
It's all about transforming the raw data into a format that the neural network can actually learn from. It's like preparing the ingredients for a recipe. You're taking the raw data and slicing, dicing, and seasoning it so that it's ready to be cooked into something delicious.
So feature engineering is all about, like, highlighting the important parts of the data and presenting them to the network in a way that makes sense to it.
Exactly. It's about emphasizing the features that are most relevant to the task you're trying to solve.
Okay.
For example, if you're building a network to predict housing prices, features like square footage, location, and number of bedrooms would be important.
Right.
While, less relevant features like the color of the roof might not be as useful.
Right. Okay, I'm starting to get the picture. So we've got data analysis for preparing the ingredients, feature engineering for, like, getting them ready to cook.
Right.
What about model evaluation? What's that all about?
Model evaluation is like the taste test. It's about assessing how well your neural network is actually performing.
Okay.
You need to define metrics that measure its accuracy, precision, and overall effectiveness. And you need to be able to interpret those metrics and make adjustments to your model based on what you find.
So it's like tasting the dish and deciding if it needs more salt, pepper, or maybe a dash of something special.
That's a great way to put it.
Okay.
It's an iterative process of testing, refining, and experimenting until your model achieves that desired level of performance.
It sounds like working with neural networks requires a lot of attention to detail and a willingness to experiment and try new things. It's not just about, like, writing some code and letting it run.
That's absolutely true. Working with neural networks requires a certain mindset, a blend of curiosity, creativity, and a good dose of persistence.
You've got to embrace the challenge and be willing to learn from both your successes and your failures.
Absolutely. And remember, this is a field that's constantly evolving.
Right.
There's always something new to learn and explore.
Speaking of learning, are there any, like, common pitfalls or misconceptions that beginners should be aware of? What are some things that that trip people up when they're first starting out with neural networks?
One of the biggest misconceptions is that you need to be a math whiz to understand neural networks.
Oh, I can see why people might think that. I've seen some of the equations involved, and it's definitely not for the faint of heart.
It's true that there's math involved, but the good news is that you can start with a basic understanding
Okay.
and gradually build your knowledge as you go. Don't let the math scare you away.
That's encouraging to hear.
Yeah.
What are some other things that beginners tend to struggle with?
Another common pitfall is overfitting. This happens when a model learns the training data too well,
Okay.
almost memorizing it,
Right.
but then fails to generalize to new, unseen data. It's like a student who memorizes all the answers for a specific test, but can't actually apply the concepts to solve different problems.
So it's like teaching someone to fish in a specific pond,
Yeah.
but they can't figure out how to fish in a lake or a river.
Exactly.
They're too focused on the specifics of that one pond.
Exactly. It's important to find the right balance between learning the training data and being able to generalize to new examples.
So how do you avoid overfitting? What are some strategies for finding that balance?
There are a few techniques that can help, such as regularization and cross-validation. So regularization basically adds a penalty to the model's complexity, preventing it from getting too tailored to the training data.
Right.
Cross-validation involves splitting the data into multiple subsets and training the model on different combinations of those subsets.
Right.
This helps to ensure that the model is learning the underlying patterns in the data rather than just memorizing specific examples.
Okay, so we've got a couple of pitfalls to watch out for. Any other, words of wisdom from the experts? What kind of advice would you give to someone who's just starting their neural network journey?
One thing that helped me a lot when I was starting out was to focus on building small, simple networks first.
Okay.
Don't try to tackle the most complex problems right away.
Right.
Start with something manageable and gradually increase the complexity as you gain more experience and confidence.
So baby steps are key.
Exactly.
Don't try to run a marathon before you can walk.
Exactly. It's like learning to play the piano. You wouldn't start by trying to play Rachmaninoff.
Of course not.
You'd start with scales and simple melodies and gradually work your way up to the more challenging pieces.
That's a great analogy. And it probably helps to prevent, feeling overwhelmed and discouraged early on.
Definitely. And another piece of advice I'd give is to really focus on understanding the problem you're trying to solve. What are the key inputs and outputs? What are the underlying patterns and relationships in the data? The more you understand the problem, the better you'll be able to design and train a neural network that can solve it effectively.
It's about being a detective, not just a programmer.
Exactly.
You have to dig into the data and figure out what's going on before you start building your model.
Exactly. And once you have a good understanding of the problem, you can start experimenting with different architectures, activation functions, and training techniques to find the best solution.
This has been super helpful. I'm feeling much more confident about exploring this world of neural networks now. But before we move on, I'm curious to hear what our listeners think.
I was just thinking the same thing. What applications of neural networks are you most excited about? And what challenges do you see on the horizon? Share your thoughts in the comments, and we'll be right back to wrap things up.
Welcome back to Demo Hub Pod, exploring the cutting edge of tech and AI, powered by AI. It's been quite a journey so far, exploring this world of neural networks, from how they work to how to even get started with them.
Yeah, it has.
But I think it's time to kind of step back now and consider the bigger picture here.
I agree. Now that we've got a handle on the nuts and bolts.
Right.
It's important to think about the implications of this tech, not just for the future of tech, but for society as a whole.
Right. I mean, it's clear that neural networks are already having a massive impact.
Oh, yeah.
And it seems like things are only going to accelerate from here.
Yeah.
What are some of the key trends or developments that you see kind of emerging in this field?
One trend that really stands out to me is the increasing convergence of different areas of AI. So we touched on this a little bit earlier with self-driving cars, which combine neural networks with computer vision, natural language processing, robotics, and more.
Right.
But this convergence is happening across the board. We're seeing AI systems that can write code, generate art, even design scientific experiments.
All these different pieces of the AI puzzle are finally clicking together to create something truly remarkable.
Yeah.
And with each new connection, the possibilities just seem to expand exponentially.
Exactly. And that raises some really interesting questions.
Yeah.
Where is this convergence leading us? What kind of future are we creating with these, increasingly powerful and interconnected AI systems?
Those are some pretty big questions. It's almost like we're standing on the edge of a new frontier, and we're not entirely sure what lies ahead.
Yeah.
I think there's a lot of excitement, but also some understandable apprehension about what this all means.
Absolutely. There's a lot of discussion about, the potential benefits of AI. Imagine a world where AI helps us tackle some of humanity's biggest challenges, like climate change, disease, poverty, even space exploration.
It's like straight out of sci-fi.
I know, right? So neural networks could play a huge role in developing new energy sources, personalizing medicine, and optimizing resource management.
It's an inspiring vision of a future where AI is used to, improve lives and create a more sustainable and equitable world.
Definitely.
But there are also concerns, right? Like things like job displacement and algorithmic bias. Those are pretty hot topics these days.
Those concerns are definitely valid, and it's crucial to address them head on.
Yeah.
As with any powerful technology, there's a potential for misuse or unintended consequences. We need to think carefully about how we design and deploy these systems to ensure that they are used ethically and responsibly.
Right.
And we need to have open and honest conversations, not just among tech experts, but with everyone who will be impacted by these changes.
That's a crucial point.
Yeah.
It's not just about the code itself.
Right.
It's about the people behind the code, the choices they make, and the impact those choices have on society. It's about recognizing that AI isn't some distant futuristic concept. It's already shaping our world, and we all have a role to play in shaping its future.
Right. And that brings us back to what we talked about earlier, thinking like a neural network.
Right.
It's not just about understanding the technical details.
Yeah.
It's about understanding the broader context, the potential benefits and risks, and the ethical implications. It's about using this knowledge to create a future where AI serves humanity, not the other way around.
It's about seeing the interconnectedness of everything, technology, society, ethics. They're all intertwined. And we need to approach AI with like a holistic mindset that considers all these factors.
Absolutely.
It's a big challenge, but it's also an incredibly exciting opportunity.
I couldn't agree more. We're living through a truly transformative period in human history, and neural networks are at the forefront of this transformation.
Yeah.
It's up to all of us to ensure that we use this incredible power wisely and responsibly.
Well said. And that brings us to the end of our deep dive into the world of neural networks. It's been quite an adventure. What are your final thoughts for our listeners?
As we move forward into this new era of AI, let's remember to stay curious, keep learning, and engage in those open and honest dialogues about the challenges and opportunities that lie ahead.
Right.
And most importantly, let's work together to create a future where AI empowers us all.
Beautifully said. Thanks for joining us on this deep dive into neural networks. We hope you learned something new and maybe even feel inspired to explore this amazing field further.
Thanks for having me. It's been a pleasure.
Don't forget to like, share, and subscribe to Demo Hub Pod, exploring the cutting edge of tech and AI, powered by AI, for more deep dives into this fascinating world of technology. We'd love to hear your thoughts on this episode, so leave a comment below and let us know what you think. Until next time, keep exploring, keep innovating, and keep pushing the boundaries of what's possible.